Hello students, in this video we are going to discuss the problems on binomial distribution. It's a continuation of the previous video. Okay, in this video I am choosing the first problem and total the sixth problem of this particular topic. Okay, in a quiz contest of answering yes or no, what is the probability of guessing at least 6 answers correctly out of 10 questions asked? Also find the probability of the same if there are 4 options for a correct answer. So we'll discuss about the first case here. So there are total 10 questions are there, and here x denotes the number of correctly answered question. And in the first case, okay, there is only 2 options, yes or no. Therefore probability is equal to 50%. That is, probability of guessing the correct answer is 50% and failure also is equal to 50%. Therefore I consider 0.5 and 0.5. Okay, now from binomial distribution we have write the formula ncx p power x q power n minus x. Substitute the values of n p x. Okay, substitute the values of npx, that is 10, 0.5 and 0.5. Since the power bases are the same, 0.5 power x, 0.5 power minus x, it will cancel. So finally we'll arrive at 10cx per into 0.5 power 10. Okay, now we'll go with at least 6 answer correctly they are asking. That means I need to find p of x greater than or equal to 6. That is p of 6 plus p of 7. There are 10 questions are there, up to 10 I will go. Now substituting the respective values of x in equation number 1, we'll arrive at this equation. Simplify using the calci. Okay, we'll get the final answer. Okay, and now in the second case there are 4 options are there. That means the probability of guessing is 25% and failure is 75%, that is 0.25 and 0.75. So substituting these values again in equation number 1, we'll arrive at this particular expression. Simplify using the calci. So we'll get these values, add together, we'll get the final answer. Therefore the probability of answering correctly whenever there are 4 options are there means 0.0197. So moving to the next problem. Okay, in a sample of large number of parts manufactured by a company, the mean number of defectives in samples of 20 is 2. Out of 1000 such samples, how many would be expected to contain at least 3 defective parts? So now in the given question there will be 27, one particular sample there are 20 items are there, so don't consider 1000 here. So like this samples there will be 1000, we'll consider this one later. Now we'll go with the one sample, it containing 20, and the mean number of defective, the mean they are given as for 20 samples it is 2, therefore mu is equal to 2, and x denotes the number of defective parts. Okay, now we know the formula for mu in binomial distribution is mu is equal to n into p. Substitute the value of n and mu, will get the value of p. So by using this, q is equal to 1 minus p, will get 0.9. Okay, substituting these values in binomial distribution, we'll arrive at this particular expression, that is 20cx 0.1 power x 0.9 power 20 minus x. Okay, now they are asking us to find at least 3 defective parts, that is p of x greater than or equal to 3. So there will be 20 items are there, 3 to 20, it's very complicated to calculate. So I'll go with the reverse order. 1 minus greater there is there means less than, equals is there means don't consider. So 1 minus p of x less than 3 means 1 minus p of 0 plus p of 1 plus p of 2. So substituting these values, x is equal to 0, 1 and 2 in above equation, will get this particular expansion, and then simplify using the calci, will arrive at these values. So final answer is 0.3230. Now this is for 20 samples. Now we need to estimate for 1000 samples. Okay, so the number of defective parts in 1000 sample is just multiply by 1000 into whatever you got the answer, it will give approximately 320 parts. That means out of 20 there are 2 defective as there. Now out of 1000 there will be 323 items are defective. Okay, now moving to the next question. If the mean and standard deviation of the number of correctly answered questions in a test given to 4096 students is r25 and root of 1.875. So find an estimation of the number of candidates answering correctly 8 or more, or 2 or less, or 5 questions. Okay, so carefully observe the given data here. X denotes the number of correctly answered questions. Given mu is equal to 2.5 and sigma is equal to 1.875. They are not given the values of P and Q here. So if at all I need to apply the binomial distributions, I require the P and Q values. Okay. To get that one, I will use these two values. We know the formulas of sigma in binomial distribution is root NPQ. They are given the value of sigma, that is root of 1.875 is equal to root NPQ. So square root get cancels, and also they are given the value mu is equal to 2.5. We know that expression for mu is equal to NP, that is 2.5 into NP, that is in place of NP I will substitute 2.5 and simplify, we will get the value of Q is equal to 0.75, and we know that P is equal to 1 minus Q, we will get the value of P is equal to 0.25. Now I require the value of N also, since in the question they are not specified the how many number of questions are there. Okay, they are specifying only total number of students, but they are not specified the how many questions are there. So calculate that one. Again I will use the formula mu is equal to N into P. Now I got the values of P also. Substituting that one, we will get N is equal to 10. Okay. Now first sub question. So substitute all these values in the formula. Now first question is probability of 8 or more questions answering correctly is, okay, 8 or more is there, greater than or equal. Since only 10 questions are there, so don't go with 1 minus, directly go like P of 8 plus P of 9 plus P of 10. Okay, substitute these values in above equation, that is the value of x is equal to 8 and 9 and 10. We'll arrive at these three values, add all the values, and now I require the estimation for 4096 students. So I'll multiply with the given obtained answer into 4096. I will get 1.765. And since I am estimating the number of students, we must approximate this one. So approximately we will get 2 students. Okay. Therefore, the number of students answering correctly 8 or more questions are 2. So second sub question, probability of 2 or less questions answered correctly, that is less than or equal to 2. So 0, 1 and 2. Okay, it's a typo error is there, make it as P of 2. Okay, substituting these values in the above, then the binomial distribution, we will arrive at this particular expression. So simplify this one. Okay, since the estimation is required for 4096 students, you just multiply the obtained answer into 4096, we will get 2152.72. so approximately equal to 2153 students answering correctly 2 or less. Okay, now exactly 5 questions. Substitute x is equal to 5, we will arrive at 0.0584 and multiply with 4096. Okay, we will get for approximately 239 students. Okay, the next problem, in 800 families with 5 children each, how many families would have expected to have 3 boys, 5 girls, either 2 or 3 boys or at most 2 girls, assuming the probabilities of boys and girls are equals. So given n is equal to 5 means each family must contain 5 children. Okay, P is equal to 0.5, that is probability of having a boy. Q is equal to 0.5, probability of having a girl. Okay, and X denotes the number of boys in a family. If you want, you can go with a girl also. Okay, now I will choose the X denotes the number of boys in a family. So from a binomial distribution, write the formula NCX P power X Q power N minus X. Substituting the values of NPQ, will arrive at this one. Observe here 0.5 power X, 0.5 power minus X, it will get cancels, and will get 0.5 power 5, that is nothing but 1 by 32 5cx. Okay, 3 boys, that means x is equal to 3. So substitute x is equal to 3 in equation number 1, will get 0.3125. Okay, now with respect of 800 families, multiply with 800, will get 250. Therefore the number of families with the children 3 boys is equal to 250. Second sub question, 5 girls, that means since I assumed that x is equal to number of boys, so in the out of 5 children all are girls they specified, therefore there is no boys, x is equal to 0, will get 0.013. that means the number of families having the 0 boys is equal to 25, either 2 boys or 3 boys. x is equal to 2 or 3. That means or means in the probability we need to add together, that is p of x is equal to 2 plus p of x is equal to 3. If you got and means you need to multiply, r is there means you need to add that one. So 1 by 32, put x is equal to 3 and 2 in the equation number 1, will get 0.6225, multiply with 800. So we will get 500 families having the either 2 or 3 boys. At most 2 girls means family can have 5 boys and 0 girls. Remember, at most means it's a maximum number. So more than 2 girls should not be present. So total in a family 5 children are there. In that 2 children, 2 are girls means there will be 3 boys. Or I will go with the starting point. At most 2 means there will be 0 also, minimum number, or maybe 1 girl or maybe 2 girl. That is all the 3 cases we need to consider. In the first case I consider 5 boys and 0 girls, or 4 boys and 1 girl, or 3 boys and 2 girls. You need to make a proper combination so that the sum cannot be exceed the 5. Okay, so that means p of 5 or p of 4 or p of 3, substituting these values, x is equal to 5 and 4 and 3 in equation number 1, will get 0.5, multiplying with 800. So there are 400 families having the at most 2 girls. This 400 maybe maybe 0 girls or 1 girl or 2 girl, that is. Okay, moving to the next problem. An airline knows that 5% of the people making reservations on a certain flight will not turn up. Consequently, their policy is to sell 52 tickets for a flight that can hold 50 passengers. So what is the probability that there will be a seat for every passenger? So they are selling the 52 tickets. That means n is equal to 52 and p is equal to 5%, that is 0.05. Probability that a passenger will not turn up, and q is equal to 0.95. 1 minus p I considered. Okay, x denotes the number of passengers who will not turn up. Okay, so from binomial distribution, write the formula and substitute all the values. So a seat assured for every passenger who turns up if the number of passengers who fail to turn up is more than or equal to 2. So as listen carefully here. So they are selling 52 tickets, but in a flight they can able to accommodate only 50 passengers. Okay, usually they know that 5% of people making the reservation the last moment, they are cancelling the tickets. Therefore, for safer side, always they will sell 2 tickets extra. But here when they are asking probability that there will be a seat for every passenger. Okay, whoever wish to travel in the flight, so we need to accommodate the seat for them. Okay, maximum I can able to accommodate 50. So how can able to some number of people are coming means can able to arrange the seat means minimum 2% does not turn up. Don't take only 2%. If the 3 persons also do not turn up means I can able to accommodate, since there are 50 seats are there and 3% do not turn up means the only 49 persons are coming, so that I can able to accommodate. If 4% do not turn up also I can able to accommodate, like that. Minimum 2, don't take x is equal to 2, it should be x greater than or equal to 2. Okay, at least 2% do not turn up means I can able to accommodate seat for every passenger, that is. Okay, so maximum I can able to accommodate 50. So if they are coming 49 also I can able to accommodate, 48 also I can able to accommodate, 47 also I can able to accommodate. Okay, that means p of x greater than or equal to 3 I need to 2 I need to find. So I will go with the reverse order, since 2 to 50 I can't able to go. So 1 minus p of x, since here greater than or equal symbol is there, I will go with less than. Equals is there, I won't consider, that is 0 plus 1. Substitute the values of 0 and 1 in equation number 1 and simplify, will arrive at 0.705. Okay, so the probability that a seat is available for every passenger is 74%. Okay, now in this video I am not given any assignment questions, since whatever the 5 questions I solved, it's very much important. Work out carefully, and that is itself, these questions itself your assignment questions. Okay, I am repeating, whatever they given the solution with that one, go through each and every step properly, and these 5 questions itself your assignment number 6. Okay, thank you. In the next video we are going to discuss about the Poisson distribution.